Hi friends, welcome to Krishang Talks. How are you all doing friends? I hope you all are doing great. Now we are going to discuss about a topic called the atomic structure of an atom. So the first topic in this is Rutherford's alpha ray scattering experiment. In this experiment, Rutherford he took a radioactive metal and a thin golden strip which is 0.0004 centimeters thin. So what he did is that he projected alpha particles, which is the helium nucleus, from the radioactive metal to the golden strip. So what he observed while doing this experiment is that most of the alpha rays they pass through the golden strip without any deflection, and some of the alpha rays they got deflected by a certain angle. We can know how they got deflected by putting a zinc sulfide screen on the other side of the golden strip. It is fluorescent, so whenever the alpha ray lands on it, we can see where it landed and how it landed. So some alpha rays they got deflected by a certain angle, and very less amount of alpha rays, that means 1 in 20,000, they got deflected along the same path. From these observations, Rutherford made some conclusions that most of the space in an atom is empty, and there is a heavy positive charge on the center of the atom. Now we are going to discuss about the Planck's quantum theory. So there was a scientist called Planck, and he suggested that the energy which is emitted by our body moves in the form of small packets called quanta, and this quanta is quantized. That means, let me explain about this. So he gave a specific formula for how the energy outgoes, and that is E is equal to h mu, where mu is the frequency and h is Planck's constant, which is 6.625 into 10 to the power of minus 34 joules per second. So this is the unit of the Planck's constant. So the energy emitted by a certain body is given by this formula. So we can express this formula as h mu, and mu can be written as c by lambda, where mu is the frequency and frequency is equal to the speed of light by the wavelength. So we can write this as E is equal to hc by lambda. So this is only for one specific quanta. If there are more quanta, the formula changes and the formula becomes to E is equal to nh mu, or E is equal to nhc by lambda. Now let's discuss about the photoelectric effect. The photoelectric effect is in which when you emit a radiation of a suitable frequency to a metal, and when that metal will eject the electron, this phenomena is known as the photoelectric effect. Is that there is a minimum frequency for the metal to give out electrons. So that minimum frequency is called the threshold frequency is the minimum frequency needed by the light radiation to remove electrons from the metal surface. So this is called the threshold frequency. So when the frequency is more than the threshold frequency or also equal to the threshold frequency, then electrons will get ejected. So what will happen to the extra frequency? Then that will turn into the kinetic energy. So there's a formula for this, and then formula is the kinetic energy is equal to h mu minus h mu naught, where h mu is the energy of the light radiation and h mu naught is the work function for that specific metal, and work function is nothing but the minimum amount of energy needed to eject an electron. So this is the formula for the kinetic energy. So this is all about the photoelectric effect. Thank you for watching this video. Please like and share to all my videos, and also subscribe to my channel. Have a great day. I will see you in my next video. Bye bye.